We're going to look at one last part of decision theory that classical decision theorists might employ. And this sort of represents sort of the classical decision theorists dipping their toe into doing things from a Bayesian point of view. So the Bayes risk. So remember, up until this point, we've defined decision rules. We have risk functions. Remember, risk functions are functions of theta. And so now what we want to do is take this idea of prior information about this unknown theta and manifest it in terms of a prior distribution. And then from there, we can take the expected value of a risk function to get a single number, which is called the Bayes risk. So the Bayes risk of a decision rule with respect to a prior distribution, pi, as you see there, is simply the expected value of the risk function using that prior distribution. And so if we put all this together, we get that expression at the very end. Because remember, the risk function, you start with the loss function, and then you take the expected value with respect to your data, with your x's. And then now we're going to take the expected value of that using this prior distribution and treating theta as the random component. Let's look at an example. So we're going to continue essentially example 7. And recall in example 7, we had one observation x which followed a normal distribution with mean theta and variance 1. And we estimated theta using square error loss. We considered this family of decision rules. And since it is important in any approach to decision theory, as it says there, we're going to consider the Bayes risk of these decision rules. So, in order to do that, we've got to come up with some sort of prior distribution on theta. And remember, this is the point where we would use our prior knowledge to do that. So we're going to use a prior distribution for theta that is normal with a mean of 0 and a variance tau squared, where tau we'll assume to be positive, because that, as we know, would be the standard deviation. And so now we take the expected value of the risk using this prior distribution and treating theta as if it were random. So let's do that. So again, the Bayes risk is the expected value using the prior distribution we have here, this normal. And recall from before that the risk function is what you see there. So now let's use the linear property of the expectation operator, and we get what we have here. And so essentially what we need to compute is the second moment of theta. Since the mean of theta is 0, then that means that the second moment is the same as the variance. So here is the Bayes risk using that prior distribution.